Hello, this is Noor and I'll be starting the explanation of our Night Tour code. So we started our code with this part where it sets up the environment for our Night Tour simulation, and we imported the necessary libraries like the tkinter for the interface and NumPy for working with the board and time for the animation delay. And we also created an 8x8 chessboard with all zeros, which refer to the unvisited squares. And we also placed the knight at the top left corner. We also defined the move counter to be 1 for the first step and defined a list to store the knight's path in it and move for all the possible knight moves for in the game. And now for the GUI setup, we started by creating the main application window using tkinter and set the title to be Night Tour. Then we added the canvas, which is where the chessboard will be drawn and place it in the window. Below the canvas, we added a label and two radio buttons that let the user choose which depth do they want, either 1 or 2, and the default is 1. And these ready buttons update a variable called depth choice, which will be used later in the code. And we use .grid to place them in the window. So for drawing the board, we defined a drawBoard function that is responsible for drawing the chessboard and the knight's position on the screen. So first it clears the canvas and prepare it for redrawing. And here the cell size, since our canvas is 400 by 400, we divided 400 by 8, the number of squares, to get each cell size, which is 50. And then the code loops through each row and column to get the 8 by 8 grid. And then the color of each square alternates between light and dark, similar to a real chessboard. And this is determined by checking whether the sum of the row and column is even or odd. So if it's even, we're gonna get this light color, while if it's odd, we're gonna get this dark brown color. And here we're calculating the position of each square in pixels on the canvas. And then to draw the actual square, we use the canvas.createRectangle because not .create square, because the graphics library doesn't have a separate function for squares. So here this line is for if a square has already been visited by the knight, the move number is displayed inside it. And finally, if the knight has moved, it draws the knight icon at its current position in the color red. So next, for this part of the code, we started by defining the reset function which clears the board by creating an 8x8 array of zeros using np.zeros and reset variables like the current, move counter, path, and the animation state. Then in the place knight function, we first check if the animation is running or not to avoid any interference. And then here we calculate which square the user clicked on by taking the mouse's X and Y pixel position from event X and event Y and divide them by 50, which gives us the size in pixel of each square on the board. This way we convert pixel coordinates into board grid coordinates. And after that we reset the board, place the knight on the clicked square at the first move, update the move counter to be 2 for the next step, the upcoming step, and update the path and redraw the board to reflect all of those changes. The last part of our GUI setup is for the buttons Start Tour, Animate, and Reset. Each of them is linked to a specific function. For example, Start Tour will call the Start Tour function, the Animate will trigger the Animate function, and Reset will run the Reset function. And here we locate each of those buttons using .grid on the canvas. Here we use canvas.bind button 1 to place the knight, and it also calls the place knight function. Here we allow the user to click on the canvas to place the knight. The button 1 event listens for the left mouse click and calls the place knight function. After that, we call the draw board to display an empty board at the start. And finally, the root.main loop starts the tkinter event loop, keeping the window open and interactive.
This is Batul, and I'm gonna go over the algorithm related part in our code. So the main function we have here is the start tour function, but I'm gonna start with some of the helper functions that are used in our main logic. The first one is the isValid function. This function checks if a specific position is valid or not. To do that, we have two conditions. The first one is that the position must be within the board, within the 8 rows and columns, or basically from index 0 to 7. The second one is that the value of the board at that location must be equal to 0, or basically that position is not visited yet. If those conditions are met, the function will return true, otherwise it will return false. The second function is getValidMoves, and this function will get all the valid moves that we can have from a specific position. Now, about the input of this function, you can either input a specific position that you want, or you can leave it empty. In the case that it's empty, or basically none, the default position that will be used is the current position that's saved in the current variable. So basically, this function is flexible in terms of the input. Now, what this function does is that it will, first of all, initialize an empty array of valid moves, and then it will try to go over each row change and column change in the moves list that we made for the valid moves, and we will try to make all those moves and save them, and then we will check if they are valid. If they are, we will append it to this list of valid moves, and then we will return the final list after going over the loop. The next function is the count future moves, and this basically counts all the valid moves from a specific location, and it will use the length function to do that. And the last helper function is the doMove. This function will basically do the actual move, so it will move the knight to that position. So the first thing we do is we check if that new position is valid or not. If it is valid, we will make the board value equal the move counter, which is incremented every time we add a new one. So here we are incrementing it. And then we will make the current variable equal to this new position, and we will append this position as well in the path array so that we can use it later on in the animation. Now moving on to the main part of the algorithm, which is the start tour function. The first thing we do is we check if the knight has been placed somewhere or not, and to do that we check if the move counter is still equal to 1. This means that the first move hasn't been made, and it will show a warning. Otherwise, we will continue by getting the depth using the .get function from the radio buttons. Then we will use a for loop to try to go over the 63 moves that are left. For each of those moves, we will first of all get all the possible moves from that position. If there are no possible moves left, it will break, so basically the loop is done. Otherwise, we will start by either using depth equals 1 or depth equals 2, depending on the choice of the user. If depth equals 1, we will start with the one-step look-ahead method, which depends on the Warrensdorf rule, and this basically states that the best move is the move with the fewest future options, and it will basically minimize the risk of trapping the knight later on in the path. So the first thing in this part is we set the best move to be none and the lowest future moves to be a very big number like infinity. Then we will try to loop over each possible moves from the ones that we already found. For each move, we will count the number of future moves, and then we will compare it to the lowest future moves variable. If it is lower, then this number becomes the new variable, and that move will become the best move. And we will keep on doing it for all the possible moves that we found before. For the depth equals 2, it's a similar procedure, so lowest future moves is a very high number and the best move is none. Then we will loop over each move from the possible moves. For the first step, we will count the number of future moves, and this will be step 1 option. For the second step, we will get the valid moves, and then we will use a for loop to increment the future moves into a total variable, and then we will get the average of all those variables. So basically, it's the total that we found divided by the length of how many valid moves we have. And then the total score will be the number of future moves in step 1 plus the average from step 2. Then we will start comparing this total score to the lowest, which was initially infinity, and we will keep on resetting it until we get the lowest future moves, and that move will be the best move. After doing all of this, we will make a move, so we will use do move to basically draw that move on the board. Then we will call draw board to print the board after we're done. And then we will use the count non-zero function to count how many non-zeros we have on the board, and that's basically the number of visited squares that we have in our board. And then we will display to the user that the tour has been completed, and we will display how many squares have been visited of the total 64 squares. And this is basically the full algorithm.
I am Tala, and today I will explain how we made the animation happen in our project. So first, we defined a prepare animation function. It sort of like prepares the environment for the animation to happen. And that happens by first clearing the board after the tour by setting it to all zeros, clearing the board, and then we extracted the first the coordinates of the first position, its row and its column, by setting it equals to path 0. Path 0 is basically the very first move that happened in the tour. And then using these extracted coordinates, we set them in our board and made them equal to 1. So this basically places the first move in the board. And the same thing for the current. We placed the current, which is the knight's position, to be at the first move. So as you notice here, wherever the number goes, the knight goes with it too. And then move counter equals 2, this we will use later. And then we will draw the board after we have set these initial conditions. And then for the main function that animates the tour, we first start by making sure that the path is not empty, because if the path is empty, that means that the tour was not taken and there was no path taken by the knight. So if not path, which means if the path is empty, show a warning message. If it's not empty, we are going to set the is animating to be true because it was false in the beginning, so we will set it to true, and then we will prepare the animation, which is the board. And then index equals 0, we will use this later. And then here we will loop through the positions, through all of the positions in the knight's path, starting from where? Starting from the second move, which is basically index equals 1, path 1. So what will happen when we loop through? We will, from the position, we will find the row and the column, and from the row and column, that the ones that we find, we will set the board equals to the index, because here it was first 1, but then now it's equal to 2. And then we want to show with the number the knight. So we do this right here by setting the current the first current row to be the row, and the second current to be the column. And then between every move, between every knight, we will wait 0.3 seconds using this function right here, and the root.update, it will force the GUI to refresh immediately every time the knight moves, so that us as users, we can see the knight moving through the board. And then we index, we increment our index for the next position in the for loop. And then finally, when we're done with all of our positions, we will return the is animating to be equals to false. Now, if for any reason the user wants to stop the animation, or basically any kind of external interruption, this will happen right here. It is if not is animating, it will break. So whenever the user wants to stop the animation or something happens, it will immediately stop and break out of the loop. And now we will see how the GUI interacts with the user and solve the problem and check animation. Now for the demonstration part of the code, we will run the file on Python. I used PyCharm. Okay. So the first thing we notice is how the GUI is set up. We have, as we coded, the grids to be light, dark, and we also find the radio buttons that we initiated in the code, and as well as the buttons to start the tour, animate, and reset. So as you can also see, whenever we first run the code, the default is equal to 1 step, because as my colleague Noor mentioned, due to the value being equals to 1, as we set it in the very beginning, the default is 1 unless the user chooses otherwise. So also we can check if we try to start the tour without placing an IT, it will give us an error. Also as the animate, because we still haven't started the tour and we don't have any path, whenever we try to animate, it will give us an error message. So we will try this, and with 1 step, and we'll start the tour. Here the knight completed all of the squares exactly once, and we can also see the animation of how it did that. Okay, and also here we can see how the number that's shown on the box, it is opposite to the number of the actual square itself. This is due to how we coded it when we show the number. Now we can also try for 2 steps. Let's try a different position. Start tour. Here also, the knight completed all of the tour, visiting each box exactly once. You can also see the animation of that. And as you can see, everything went on perfectly, and we can also reset if we wish. And that was it, and thank you very much.